Okay, so last week we learned about sample space. We were introduced to it in this problem here. If you remember, Jamal was flipping some cups, and when he flipped the cups, he could flip it on its side, right side up, or upside down. Those were the only possible outcomes. The possible outcomes are called the sample space. So anytime you are running an experiment, the outcomes that are possible are the sample space. So for example, when you flip a coin, and this is always going to be my go-to example, heads and tails are your only options when you flip that coin. It's not going to land on its side as much as you would like it to. It's not going to. The only options are heads and tails, so that is the sample space. Looking at these examples here, drawing a colored cube from a bag with 2 green, 1 red, 10 blue, and 3 black. Our options here are green, red, blue, and black. There, at any point, you do not need to write 2 green, 1 red. I don't need the numbers. I need the options. So red, green, blue, black. The only time that you will write numbers when you're talking about sample space is when the options are numbers. So right here, rolling number cube with the numbers 1 through 6 on its bases, the options are 1, 2, 3, 4, 5, 6. That's your sample space, are those numbers, because those are the possible numbers you can land on. But that's the only time that you will have the number part in sample space. The other thing you need to think about is the fact that in sample space, things don't repeat themselves. So looking at this letter here, probability, there are 2 B's and 2 I's. That means that your sample space is not going to be probability spelled out. It's going to be PROBAILTY, because those are the possible letters that you can get. You are not including anything that repeats itself.